In Lesson 9.6 Part 3, you will classify conic sections. The standard form for a general second degree equation is written on this page. We can use the discriminant of b squared minus 4ac to classify a conic. If the discriminant is negative and b equals 0 and a equals c, then the conic is a circle. If the discriminant is negative and either b does not equal 0 or a does not equal c, then the conic is an ellipse. If the discriminant is 0, the conic is a parabola, and if the discriminant is positive, the conic is a hyperbola. So in our first example, we're going to use the discriminant to classify this conic section. We're going to write its equation in standard form and graph it. So first let's pick out our a, b, and c values. A is multiplied to x squared, so it's 2. B is multiplied to xy, it's 0. And c is multiplied to y squared, so it's 2. Our discriminant is b squared minus 4ac. So b is 0, so I have 0 squared minus 4 times a, which is 2, times c, which is 2. So we're getting a discriminant of negative 16. Now because the discriminant's negative, b equals 0, and a and c are equal to one another, we know that this is a circle that we're graphing. So we'll get the equation in standard form. I need 1x squared and 1y squared to complete the square on x and y. So I'm going to start by dividing every term in this equation by 2. So I'll get x squared plus y squared minus 6x plus 2y plus 1 equals 0. Okay, and now I want to complete the square on x and y, so I'm going to get my x terms together. I'm just going to use the commutative property to move things around, and I'll get my y terms together. And I'll move that constant term to the right-hand side. Okay, now I'm ready to complete the square on x, so I'll take that value that's multiplied to x, negative 6. I'll divide it by 2 and square it. That's going to give me negative 3 squared, or 9. So I'll add 9 to both sides of this equation. And then I'll complete the square on y by taking 2, which is multiplied to y, divide it by 2 and square it. So I'm getting 1 squared, or 1. So I'll add 1 to both sides of this equation. Okay, now I'm ready to factor my perfect square trinomials on the left. To factor the first trinomial, I'll take the square root of the first term, which is x, the sine of the middle term, which is negative, and the square root of the third term, which is 3. And I'll do the same thing with my perfect square trinomial in y. Take the square root of the first term, which is y, sine of the middle term, which is plus, and the square root of the third term, which is 1. Now on the right-hand side, negative 1 and 1 are 0, so I'm just left with 9. Okay, now in the standard form, I can pick out the center of this circle. The center is hk, 3 is subtracted from x, that's my h value, and negative 1 is subtracted from y, that's a k value. And r is the square root of 9, so 3. So now I'll graph that center of 3, negative 1, and I'll use the length of the radius, 3, to go up 3 units from that center, left 3 units, down 3 units, and to the right 3 units. And then draw this circle through those 4 points. In example 2, we want to use a discriminant to classify the conic section. We want to write its equation in standard form and graph it. So again, let's pick out a, b, and c. A is equal to 4, b is equal to 0, and c is equal to negative 1. The discriminant is b squared minus 4ac. So b is 0, so we have 0 squared minus 4 times a, which is 4, times c, which is negative 1. So here we're getting positive 16 for a discriminant. Since the discriminant is positive, our conic section is a hyperbola. We're graphing a hyperbola. So we'll need to get the equation in standard form by first getting our x terms together and our y terms together and moving that constant term to the right. Okay, now before I can complete the square on x, I need to make sure I have 1x squared. So I'm going to have to factor 4 out of my x terms. That'll leave x squared minus 4x, and I'm going to leave a space to complete the square. I need to factor negative 1 out of my y terms in order to have 1y squared. And now to complete the square on x, I'll take negative 4. I'll divide it by 2 and square it. So negative 2 squared is going to give me 4. Now I'm adding 4 inside parentheses, but remember I'm factoring 4 out of those terms, so 4 times 4 when I distribute is 16. I'm actually adding 16 to both sides of this equation. Okay, and now to complete the square on y, I'll take 4, which is multiplied to y, divide it by 2 and square it. So I get 2 squared, which is 4. I'm adding 4 inside parentheses, but I'm distributing through by negative 1. So negative 1 times 4 is negative 4. I'm really subtracting 4 from both sides of this equation. Okay, now I'm ready to factor on the left. Take the square root of the first term, sine of the middle term, and the square root of the third term. I can factor my perfect square trinomial in y also. Square root of the first term, sine of the middle term, and square root of the third term. On the right hand side, 4 and negative 4 are 0, so I just have 16. And now because a hyperbola has to have 1 on the right hand side, I'm going to divide every term by 16 in this equation. So in that first term, 4 is going to cancel, so I'm going to have x minus 2, the quantity squared, over 4. Nothing cancels in the second term, so I have y plus 2, the quantity squared, over 16. And I have 1 on the right hand side. Okay, now the center of this hyperbola is equal to 2, that's what's subtracted from x, and negative 2, that's what's subtracted from y. Okay, our a value is 2, and our b value is 4. Now because my x term is positive, I know that this hyperbola has a horizontal transverse axis. So on that horizontal transverse axis, I'm going to graph that center of 2, negative 2. And I'm going to go 2 units left and right of the center, a distance of a units to find the vertices. And then I'm going to go up a distance of b units, or 4 units, and down 4 units from the center so that I can draw a box through those points. A box that I'll be able to draw my asymptotes for this hyperbola through. Now when we draw those asymptotes, they go through the corners of the box and through the center of the hyperbola. So now I'll draw the branches going through the vertices, left and right of the center, and following the asymptotes as closely as I can without touching the asymptotes or crossing them. In example 3, we want to use the discriminant to classify this conic section, then write its equation in standard form and graph it. So our a value is 0 since there is no x squared term. Our b value is 0 since there is no xy term. And our c value is 1 since that's what's multiplied to y squared. Discriminant, b squared minus 4ac. b is 0 and a is 0. c is 1, so our discriminant is 0, which means this conic section is a parabola. When the discriminant is 0, our conic is a parabola. So we need the equation in standard form, so I'm going to leave my y terms on the left, and I'm going to move that x term to the right and that constant term to the right. And now I can complete the square on y by taking 4, which is multiplied to y, dividing it by 2 and squaring it. So I get 2 squared, which is 4. So I'll add 4 to both sides of this equation. Now I can factor on the left, factor that perfect square trinomial into a binomial squared. Take the square root of the first term, the sign of the middle term, positive, and the square root of the third term. Okay, on the right hand side, I can combine like terms. Negative 16 and 4 is negative 12. And then on the right hand side, I need x minus h in parentheses, so I'm going to have to factor 4 out of those terms, leaving x minus 3. And then I need to know my p-value, so I'm going to factor 4 out of that focal width, and that's going to leave a p-value of 1. So from the standard form, I can see that the vertex of this parabola, HK, H is 3, that's what's subtracted from x, and K is negative 2, that's what's subtracted from y, and P is 1. So, graphing that vertex of 3, negative 2, and deciding whether this parabola opens up, down, left, or right. Since y is squared, I know it's opening left or right, and since p is positive, I know it's opening right. So p units, or 1 unit inside this parabola, is where I'm going to find the focus, and p, or 1 unit outside the parabola, is where I'm going to find the directrix. Now the focal width for this parabola is 4, so I'm going to go up 2 units from the focus and down 2 units from the focus, so I have a total focal width of 4 units. And then draw my parabola through those points, the end points of the focal width, and the vertex. Include with your notes of this video guided practice problems 10 through 13 on page 654 of your textbook.